Okay, let's start. So let me power on the lab first so that we can log in and check. Okay, no need to log in. We can check it here itself. Yeah. So let's start. So yesterday, any queries on yesterday's discussion? What we tested on the thin and thick provisioning?
No.
You understood what it is, how it works?
Yes, yes, yes.
Okay.
Yes.
So let's understand another theoretical concept today. Most of the excuse me, sorry. Most of the scenarios will not be able to test it on the fiber channel. So let's understand theoretically how it works. Okay, I said normally we will have how many controllers in storage?
Two controllers. One CPU.
Storage controller 1 and storage controller 2. Okay, and all these storage controllers will in turn connect with, right? In turn connect with what it has? These shelves. Agree? That is what we discussed so far in last few sessions. On the back side, these shelves are connected to both of them, right? The connectivity is
Yeah.
something like this. Be on mute. Okay. The backend connectivity is little tricky that we are not going to discuss here. Okay, but imagine controller 1 has a connectivity with all the disk shelves. Even controller 2 also has a connectivity with all the disk shelves. And in between both the controllers, there is a connectivity called interconnect. Okay, controller interconnect. So, what all the protocols that system will support? This system will support SAN and NAS both. Agree? In SAN, we have two. In NAS,
Yes.
we have two. In SAN, it is iSCSI, which we already tested. In SAN, we have fiber channel, which we cannot test it, but I'll explain today in brief. Also, in NAS, there is a concept called NFS and another concept called CFS. Okay, with respect to our VMware infrastructure or VMware administration part, you still need to test NFS and fiber channel. Anyway, I'm sorry. Fiber channel, you'll not be able to test it. I'll explain it in theory. And tomorrow, if time permits, we'll test the NFS small topic so that we can do it tomorrow. And CAFS is just a protocol, okay, that we will use it for Windows file shares. That we cannot test it in VMware. I mean, it is not related to any VMware administration part. It's purely Windows administration part, I can say. But in short, this box can support all the four protocols. Fair enough. Now I have explained the iSCSI concept and we tested the iSCSI. So how many variants you have in iSCSI? Speed variants I'm talking about.
1 Gbps, 10 Gbps.
Perfect. So remember if I'm saying 1 Gbps from here and from here, either one or two or four or 10 cables, doesn't matter. Okay, from here and from here, there must be some 1 GB cable that will go out. Imagine the blue ones are 1 GB cables. Okay, means these two controllers will support 1 GB speed with these blue cables. Means normal Ethernet cables can be connected here. Agree? Disagree? Okay, that is first basic thing. 1 Gbps. I'll say I. I means Ethernet. 1 Gbps Ethernet. And also, if you want to use 10 Gbps connectivity, as you said in iSCSI, you should have at least two or minimum four, I'll say, right? Second one, 10 Gbps iSCSI, which is again over the Ethernet. Over the Ethernet means you'll have IP address, you'll have communication over the TCP/IP. Agree? This is this is basically used for iSCSI based on the requirement. If you are using 10 Gbps, there is no point of discussing 1 Gbps over iSCSI. Fair enough? Or any questions? Understood? If I am using 10 GB connectivity across the company or across the data center room, what is the point of discussing 1 Gbps? Anyway, I am getting a 10 GB speed over the red cables. Why I will use the blue cables again? Even though if it is there, I will not touch it. You agree on this?
Yes.
Okay. Now these 1 GB 1 GB cables is there, no? Okay. They will also connect it to some of the switches here in the same room. They will connect somewhere in the switch like this, right? And the red ones, they have a 10 GB cable switches. This goes to 10 GB switch. This goes to 10 GB switch. 10 GB switch, right? This is 1 GB switch and this is 1 GB switch. Okay, now these two storage controllers via this 1 GB, they will use for CFS, NFS. Agree or disagree? And these red cables, they will use it for iSCSI purpose. Okay, so far no questions. Now I have a requirement. I have a requirement. Customer is asking for fiber channel. So again, remember, if I have mentioned iSCSI means you will have a two here and you will have a two here, two iSCSI ports or two iSCSI adapters which goes to the same switch or a different switch. Clear? Okay. Now let's move on to fiber channel. Again, you'll have two more here, two more here. The green ones, you call it as green ones. What you call it as? Green ones? Let me go to HBA adapter. Go to images. This is how it looks like. HBA adapter TX RX. TX RX. Okay. What is TX RX in this one? Right? Enough. Transmit and sorry, transmit and receive. Send and receive in short way. Okay. So even if you look at FC cable, you'll have FC cable like this. Normal 10 GB Ethernet cable is something different. Whereas I cannot see any 10 GB Ethernet cable here. Okay, let me check the 10 GB copper cables images. This is 10 GB cable. Okay, this is one side, this is other side of the cable. You just insert into the switch, right? But when it comes to FC cable, you see this FC is something like this. So TX RX, one cable is for transmitting, another cable is for receiving the data. Means if I zoom it a little bit, this has two things and this has two things. Transmit, receive. Transmit, receive. Understood? Guys,
Yes. Yes.
okay. Similarly here, this you call it as HB adapter. The green ones you call it as HB adapters. Okay, so HB adapter. I don't think currently they are selling something. Even such results, I don't think it will show up. But HBA. At least we got something in the picture. Transfer rate 16 Gbps. It is like this. Okay, two ports, dual port, 16 Gbps. What is the cost? Look at. Okay, it's not cheap. QLogic 16 GB HB adapter cost is this much. Maybe if you have a premium customer support account with the vendor, okay, I don't know whether it is a less or more. Okay, you might get some discount. That is what I can say. Right. So like this, I have four adapters, this kind of adapters, two here and two here. Now how the configuration is? Configuration is something like this. This you call it as want the models Cisco let's say you'll get a switches like this. Some of these are, if you look at the bottom, these are empty slots, universal switches. Okay, anything storage networking. These are empty slots you will get. Okay, empty slots. What you have to do? You have to you have a ports like this, right? You'll have ports like this on the switch. Agree?
Yes.
Okay. So in this port, you will get an empty slot. Slot is empty. You will get a ports, 48 ports, okay, or 128 ports, whatever. They based on the 256 ports, based on the configuration and based on the cost, you will get a switch, okay. But that will come with empty slots. So you need to purchase these kind of devices, SFP modules, okay. So again, here HB adapter I said 16 Gbps. So what kind of SFP module we need to purchase? 16 GB SFP like this. You need to select. Let's see. You see here, second line, 16 GB software FC SFP, 16 GB speed. So these kind of devices you need to purchase it. One device cost is okay, maybe 50% discount still is on higher side, $250. This one SFP module. Okay, so you need to have SFP modules on this. Okay, sorry boss, half I want to use it for FC, half I want to use it for iSCSI 10 GB. Same switch, SAN switch. SAN switch means SAN has two protocols. Common switches are available in the market. Okay, universal switches you call it as 10 GB SFP. If you look at this is 10 GB SFP. Oh no, this is not the SFP. This is fiber channel SFP, and this is iSCSI SFP. SFP second line 10 GB. You look at or look at this. This is 10 GB. This is fiber channel. We have a read and write 10 GB HP 10 GB SFP. This is fiber channel, not the iSCSI. Right? There is a small difference at the notch. Okay, so if you purchase 10 GB SFP modules, you can insert those, and then these ports will act as a iSCSI ports. And if you purchase fiber channel SFP module, FC SFP module, and insert, that particular port will act as a fiber channel port. That is what the meaning of universal switch. Universal switch can support both iSCSI and FC based on the SFP module you purchase it. Agree? Any questions?
No, sir.
Okay. Now, what I have to do? I have to take one cable from here and connect here. I have to take one cable from here, connect here. Similarly, I have to take one more cable here, connect here. cable here and connect here. Same thing, understood? High availability. If something goes wrong, you can still access the data. Okay. So let's move that little upside. So what I will do, imagine I have one VMware cluster. I have one VMware cluster. Also, I have one Windows server. Also, I have one Linux server. All the three, Linux, right? Windows, right? And ESXi cluster. Cluster means it has multiple hosts. What I'm talking about is all about a physical servers. This is also physical, this is also physical, this is also physical. Cluster has, imagine, n number of hosts. How many number of hosts that cluster can have, boss? 64.
64.
Now in this picture I'm just representing only two. Like this you have 64 in the cluster. So again, these HBA adapters you need to purchase here as well. You need to have two HBA adapters. Agree or disagree?
Yes.
Okay, two HBA adapters and connecting like this. One cable here, another cable here. Okay, like this. So if I have a n number of servers in a data center, one cable should go here, one should come here. And if I have one more Linux server, same thing, doesn't matter. How many? This storage system can support, let's say, 2000 hosts I have in my data center. How many cables that these two switches? This should accept 1000 cables. This should accept 1000 cables plus these four cables. 1, 2, 3, 4. That is mandatory, right? Come on. Any confusion? Any confusion?
No, sir.
Now, now this is the physical cabling architecture, or you call it as blueprint of fiber channel connectivity. This is basic block diagram. Okay, you take any big customer or any small customer, if they are using fiber channel, they should follow this kind of setup. Irrespective, it is 16 Gbps or 4, 8 or 12 or 10 or 24 or 32, whatever the Gbps connection, what they have in between. The speed will vary, but this connection type or connection diagram will not change. Agree on this?
Yes.
Okay. Now, there is some concept called SAN zoning. Okay, SAN zoning. There is a concept called SAN zoning. We'll understand what it is quickly. Okay, now in iSCSI, to whom we assign the storage? Come on, in iSCSI, to whom we assign the storage? IP address, host name, or
IQN.
MAC address? Yes.
IQN.
Okay. Yeah,
IQN.
exactly. In iSCSI, we assign the storage to IQN number that is for unique for each host. If I have a 2000 host, I will get 2000 IQN numbers or 4000 IQN numbers if I am looking at the HBA. Sorry, if I am looking at the high availability. Agree?
Yes.
That is different.
Yes, sir.
Now in this fiber channel, to whom I will assign the storage? In iSCSI, we are assigning to IQN number which is unique. In fiber channel also, there must be something unique. Then only it should work. Agree? So what is that unique? Every HBA adapter, every HBA adapter will have unique address called WWN, worldwide number. Okay, this is unique. How it looks like? Let's see in the pictures at least. VMware WWN. Let's see images. It will be showing like this. Able to see something? This
Yeah.
is the number. This is the hexadecimal number. Okay, where you will go and check. If I go to VMware, log into any host, and you can you can add software iSCSI adapter, and you'll see some IQN number will be created, right? On this is my main host. Okay, here I have only one controller which has three devices. One controller which has three devices attached. Three devices is these three. One adapter and which has three devices attached. One 1 TB, another 1 TB, another 120 GB. Two are SSDs. Okay, two SSDs, one normal SATA. Okay, Samsung 1 TB SSD, and this one some small company, I don't know, I don't, Kingston maybe, something I don't exactly remember. 120 GB, and this is 1 TB SATA. Okay, similarly, if I go to adapters, HBA1 and HBA2, adjacent to that, here it is something different is showing. Normally it will show something like this, device type, WWN number. Device is just like your device only. Okay, and type is, if it is iSCSI, BlockSCSI, fiber channel, it will show you that thing. And the if it is a fiber channel, the unique number under WWN number. In if it is iSCSI, under unique number you'll see IQN number. Understood? Like this. Storage adapters. Like this, you'll see the numbers. Let me, fine. It is not clearly showing, and you have a command prompt as well. Like this, you can run the commands. Even in Windows Server, okay, you have a commands. You can get the WWN numbers. Linux and Windows and Linux. Log in into those servers. You can run the command that will give you output of WWN number. Okay, Windows 2016 WWN you can run command like this. What command they run? It is not visible here. Normally, if you go to device manager, you'll see the WWM numbers. That's different. Yeah, get initiator port. You'll get an output like this. FC info is also another command, and get initiator port also another command. Okay, so if you can run, right, get, if you open a PowerShell, sorry, what is that command? Get hyphen, there's nothing. If it is there, then definitely you'll get an output. Okay, let me run as admin and see. Nothing, no output, nothing is showing. There is some adapters, fiber channel iSCSI, you'll get an output. Okay, so similarly, you will get Linux also. Okay, so for each host, how many WWN numbers will be there? Hmm?
So, WWN number,
Yeah. For each port, one WWN means if the server is equipped with two HB adapters, there will be two WWN numbers, right? How many hosts that cluster can hold? How- hmm?
64.
60? Vivek, come closer to the microphone and talk.
64.
60?
4.
Sunil, are you getting what he's saying?
no.
No. I don't know from where you're talking.
Hello. Hello.
Yeah.
In a cluster, na?
In a cluster, how many hosts that you can keep it?
64 hosts. We can
64?
4.
Okay, finally I am able to hear you. That 4 word I want to heard of it. Okay, that is the reason why I'm asking you multiple times, and you're speaking like you put your microphone in some other room and you're sitting in some other room.
No, it is near me, but I don't know what is happening.
Yeah, you can ask Sunil if you want. It is not the case with me. Even he is also unable to hear you. Okay. So 64 hosts you have in the cluster. How many WWN numbers you'll have?
64 WWN number.
64 into 2, 128.
Into 2 into 2, 120.
Okay. A little mathematics is required here. At least a little. Okay. That means you are not concentrating. For one host, Sunil said 2 WWN numbers will be there. Okay. How many hosts in the cluster? 64 hosts. How many WWN numbers will be there? 128 WWN numbers. Fair enough? You have something to clarify.
Yes.
Okay. Now you can create one LUN here. Agree? Of 4 TB. 4 TB. Okay. Now the aim is this 4 TB LUN. I want to assign it to all the clusters in the vCenter. Sorry, all the hosts within the cluster in the vCenter. I can have a multiple clusters, by the way. Not I can create a multiple clusters in vCenter. Prod, dev, test. That is what we created, right? But within a cluster, you cannot add more than 64 hosts. Now I want to assign this 4 TB LUN to cluster 1, which is prod, which has 64 hosts. So to whom I need to assign? To whom I need to assign? All the 128 WW numbers I need to assign. Then only they can see the LUN. Just like your iSCSI. What I did, I went to each and every IQN number rescan. IQN number rescan. I did it right.
Yes, yes.
Okay. Similarly, if you are using fiber channel here, you can go to storage adapters. Right click, rescan. Right click, rescan. How many WWN numbers you will have? How many HB adapters per host? 2. So on the 2 hosts, you have to rescan it. Sorry, 2 adapters. You have to rescan it. Agree? So in short, I need to assign 128 WWN numbers for this. It is really hard for storage administrator to assign individual WWN number to learn. How many WWN numbers he'll sit and add it. So the zoning is helping in such a way you create 2 zones. Why 2 zones? On switch 1 zone. On switch 2, another zone. 2 zones. And give the same name. Logical name. Can I give a logical name? Give some logical name, and under the logical name, create a 2 zones. One zone is on switch 1, another zone is on switch 2. Possible?
Yes.
Okay. How to do that? I'll show you the picture. You can watch this video on YouTube. I'll ping you this one. They will explain how we can do this one. That is what? Create alias, create a zone, zone config, activate. Zone means logical boundary. Alias means soft name, and zone config, create it and attach to alias and activate. That's it. Okay, I'll ping you this video. It will help you. Go back, and if you look at this picture, you will see this window. How you access this window? Very simple. This switch has one IP. Even this switch has another IP. Even though they are fiber channel, in fiber channel there is no IPs, nothing. Okay, remember, in fiber channel protocol, you no need to assign any IP address or nothing. Everything over WWN number only. Remember, okay. But someone as a network admin, as a storage admin, he has to access the SAN storage switches, right? Those switches he need to access it. How he will access it? Over the IP only. So for the entire box, there will be one IP. Agree or disagree?
Yes.
Okay, you take that IP, put it on the browser, you'll get this window. Okay, in that, if I log in into switch 1, how many WWN numbers I will see? Switch 1, how many WWN numbers in switch 1? From each host, one cable will go to switch 1. Means how many hosts in the cluster?
64.
How many cables connected to the switch 1?
64.
Okay, 64. In switch 2, leave about this Windows and Linux. I don't want to confuse more.
64.
64. Okay. From controller 1, how many cables onto switch 1? Controller 1,
Switch one, it's 60. It is one cable only.
1 cable. From controller 2, how many cables onto switch 1?
One cable.
1 cable. And from switch 2, sorry, from controller 1, how many cables to switch 2?
One.
From controller to how many cables? 1. Now tell me how many WWN numbers that switch can see. These 64 and this and this. These two also having the WWN number, right?
Yes, 66.
Understood? Concentrate and put some logic on your mind. Understood?
Yes.
Yes.
Okay. So create a boundary and login into second switch, create a boundary, give alias name. Alias name means give some name. That's it. Okay. And add this and this boundary to this name. This name visible on the GUI of the storage system. Storage system has some GUI, web browser window. In that web browser, create a LUN, next select the size 4 TB, next assign it to this name. This name will be visible on the screen. Okay, and assign it to this, next finish done. So this 4 TB is assigned to this name, and this name has a two boundaries, and it can travel like this and it can travel like this. So every host can see this 4 TB, and what you have to do, you have to rescan the adapter. No need to configure anything on the VMware side. Everything will be done on storage side only. It's purely storage admin task. 90% of work is storage admin task. In fiber channel, 90% work is storage admin task. Your duty is put a put the WW numbers into one Excel. Okay, 64 host 1 HBA1 HBA2, host 2 HBA1 HBA2, host 3 HBA1 HBA2. That's it. And on the next tab put storage requirement. I need 5 LUNs of 4 TB each. 5 into 4 20 TB is the storage I require. Send a sheet to storage admin along with the ticket number. You need to open a ticket, right? Or you need to open some project if you are doing for new implementation. Okay, give it to storage admin. What he will do, he will open that sheet, he will log in into the both the switches, and he will create a zones, and he will log in into storage system, and he will create the LUNs and assign it to the same logical name, and he will send an email to you saying I'm done, please check. As a VMware admin, what you have to do, you have to log in into the vCenter and rescan all the HBA adapters. Rescan all the HV adapters. Automatically you will see raw device, 5 raw devices here. 5 raw devices means 5 into 4 20 TB is showing here. Same thing here, and same thing here, and same thing on the last host as well in the cluster. Understood? Just like what we did in the iSCSI. LUN 10 20 30, it is those things are visible in all the host. Similarly, in real time, if you are using fiber channel, okay, whatever the storage that you requested, the same storage will be shown in the all ESXi host within the cluster. Fair enough? Understood? Once the raw device is visible, you know what to do. Right click, format, create a data store, use it. Okay, once you create a data store, that same data store is visible in all 64 hosts with the same name. LUN 10 20 30, we created 3 data stores. All the 3 data stores are visible in host 1 2 3 or not? It is visible, right, with the same name.
Yes. Yes.
Similarly, if you create 5 data stores, data store 1, data store 2, data store 3, data store 4, data store 5, in this host, same data stores visible here, and same data stores on the last host within the cluster. It is visible. All the data stores are visible in all the hosts within a cluster. Clear?
Yes.
Okay, this is how you will configure, and this is how the backend connectivity is, and this is how you have to request for a storage when you are using fiber channel. Practically, will not be able to implement this in our lab because of the limitations, but the procedure is more of similar what I have explained, and also the configuration part is more of similar what we did in the iSCSI. Clear? Any questions on this?
No.
No? Yes?
No.
Okay. So let me stop here.